This video will cover question 50 of the 2016 Section 1 TSA paper. So we're given this diagram here, and we're told that rolls of a particular wallpaper have this repeating pattern every 60 centimetres along its length. Each length, which we're told in the question, is called a drop. So each drop is 10 metres tall and 50 centimetres wide, and it has to be used to paper a wall which is 6.2 metres wide and 2.5 metres tall. Okay, so then we're asked to work out how many rolls of this wallpaper is needed in order to paper this particular wall in such a way that the pattern is at the same vertical height each time. So it isn't uneven, it has to be level with each other, the tops and bottoms of the patterns at each point. Okay, so bearing that in mind, we have to think about the drops that we have. So obviously they'll be covered in this pattern every 60 centimetres. So in a 10 metre long strip, we can say that there are 16 patterns in this 10 metre roll, 16 full patterns, because 60 times 16 is 960 centimetres, which is 40 centimetres shy of 10 metres. So there'll be a small 40 centimetre strip left over of a pattern. Okay, so we can bear that in mind. Now let's have a think about our wall. So it's 2.5 metres tall, 2.5 metres long, therefore that's just over 4 patterns long, bearing in mind that our patterns are 60 centimetres tall. So we'll have just over 4 of these horizontally in a series of strips. But how many strips wide is it? Well, how many drops wide is it? Well, it's 6.2 metres wide, and therefore we can say that it's just over 12 drops wide. Now you'll notice I put 5 here. The reason for that is, functionally, we'll need 5 of these patterns in order for the pattern to be perfectly repeated between each strip. That's because this component here, this section of the 5th pattern in our roll, has to be identical each time and therefore has to be cut in the same way each time. Okay, so functionally we'll need 5 patterns tall, and functionally, since this isn't perfectly divisible by 50 centimetres wide, we'll need 12 drops wide, which is functionally 13. Okay, so bearing that in mind, we'll have 13 of these wide, and we'll have 4 patterns long. Okay, so how many of these strips are needed in order to fulfill these requirements? Well, let's have a think about it. How many times can this one roll fulfill the requirement to produce 4 perfect patterns and then 1 pattern which is cut off in a certain way each time? So we need 16 divided by 5, i.e. 3 times. Since if we were to cut this roll in this way, so this is our first roll, if we were to do our first cut here, our second cut here, and then dispose of this place, that's our first piece that we can move across. Moving on, we can cut here to satisfy our second column. We can cut here and then dispose this material. We can cut here and then dispose of this material, and then from our 10 metre roll we can produce this covering of our wall. We're told in the question that no joins can be made in one vertical drop, so we can't join up these waste pieces of paper, so we have to cut them here, and then we can only produce 3 horizontal cuts. Okay, so how many of these 3 drop wide strips will we need? Well, we need to have our total covering to be 12 drops wide, so no, actually it needs to be just over 12 drops wide, i.e. we need 13 drops wide. So in order to get that, we can add 1 more on, so we have 6 so far. Another, now we have 9. Another, now we have 12, but we're just over 12 since it's 6.2 metres divided by 50 centimetres, so that leaves 20 centimetres left over. And then we'll need a separate 5th strip to make up for this area here at the very end. So in order to cover the wall and have the patterns matching horizontally every time, we will need 5 drops. Okay, so 5 rolls, and then we can say our answer is going to be option C. So this is a rather difficult spatial reasoning question in which you have to use the fact that these measurements are imperfect and therefore there will be some waste over material and it won't fit perfectly. I think in terms of a question that you should be able to do in the TSA time, this is quite a demanding one. Perhaps if these were perfectly divisible by 60 centimetres, the question would be more doable. So this might be the sort of question where, if you recognise you're not going to get particularly far, it might be one to leave for the end.